Hi guys, this is the second lesson of the Unit 2 or the Chapter 2. It is about the rational expressions simplification. So in this case, you're going to deal with the rational expressions which are in the fraction format, and their addition, multiplication, subtraction, and addition. Okay, or multiplication, division, subtraction, and addition. So when you do this, this is pretty much the same as how you do the fractions. Okay, so one simple review of it is that when you have 1 over 2 plus 4 over 2, you can simply add the numerators because you have the same denominator. Now, when you multiply, when you, let's say, have 1 over 2 times, let's say, 1 over 6, you basically multiply top by top and the bottom by bottom, so this becomes 1 over 12. And another example could be if you have, let's say, 4 over 6, and 4 over 5 times, let's say, 15 over 12. Remember this, that you can cross these two in a crossways by in order for you to do the simplification. So 4 goes into 12 3 times, so that 12 becomes 3, and then these two actually can also be done in the same way. So the 15 becomes 3, and 4 and 5 actually becomes 1 and 1. So you're reducing in the cross ways and as well as the up and down ways. Now 3's can be reduced as a 1, so the answer actually becomes 1 over 1, which is 1. Now we're going to use this concept. Okay, we're going to use this concept. One more thing that you have to be careful of is the factoring. Okay, so again, factoring has to be in place in order for you to do this very simply and easily. So let's take a look at the first example here. So we have simplified and state the restrictions. So when you do this, when you multiply, the very simple first thing is that you have to factor it. Okay, so you have to factor it very fully. Now, one thing that you have to remember though is that when you factor it fully, before you cancel anything, you have to state the restrictions. And there is a reason why, okay? Because if you cancel it and try to find the restrictions, then there's a high chance that you're going to miss the whole. So in this case, make sure that you find the restrictions before. Okay, so it's basically all the values that makes your denominator 0. And then you either cross cancel it or up and down cancel it, and then you multiply top by top and the bottom by bottom. And that's that pretty much. Okay, if you need to expand the numerator, you can expand it and then factor that again to make it even simpler if you like. Okay, so if you take a look at the first example here, you have 8x squared plus 14x plus 5 over 16x squared minus 25 times 3x squared over 6x squared plus 3x. So the first job is for you to do is the factoring. So if you factor the top of the first fraction, then this becomes 4x plus 5 and then 2x plus 1. So hopefully you get this by taking your own time. And then the bottom is a difference of squares, so we get 4x plus 5 and then 4x minus 5, and then times 3x squared over 3x and then 2x plus 1. Now then, if you take a look at this, we can cancel this, but again, remember, before you cancel it, you list the restrictions. So here are the restrictions. So the restrictions are x cannot be negative 5 over 4, and x cannot be positive 5 over 4, and it cannot be 0, and cannot be negative 1/2. Now, again, to do a brief review on how I got these numbers is because you have to make these bottom parts 0, each and individual. So for example, here we have 4x plus 5 equals 0. So then we have 4x equals negative 5, and then obviously you divide everything by 4, so x equals then negative 5 over 4. And same drill for the others. Okay, same drill for the others. So find all the restrictions that x cannot be these 4 numbers, then you start canceling. Okay, so now we cancel. Now I'm going to use a different color. So for the canceling, I'm going to use red. So we have 4x plus 5, 4x plus 5, and then we have 2x plus 1 and 2x plus 1. Remember this, you can cancel or you can reduce in a cross manner or also up and down manner. So we have then 1 over 4x minus 5 times, and then, oh, there's more actually, sorry, my bad. And then we can cancel these 3, and then the x's can be gone too, right? So then we have x over 1. So this becomes then x over 4x minus 5. Again, as you can see it, if you take a look at the final product and the one before the reduction, the denominators are significantly different, meaning your restrictions may look different, and that's why we have to take the restrictions before canceling, okay? So that's the multiplication, okay? It's not so bad, it's basically just multiply, right? Now, then let's take a look at the second one. So this one, I want you to actually pause the video and then try this on your own and see whether you can do this, okay? So pause the video. Now, hopefully you have tried it. So now this becomes, we have to factor it. Now, the first one then becomes 2x here, 2x here, 3 and 1, and subtracting n plus there, over, now we have 2x minus 1, and then 2x plus 1, and then times, we have 8x squared over 4x, and then x plus 3. So hopefully everything is going so far okay. Then we have to cancel things around. So I'm going to use red. So then if you take a look at this, we have 2x minus 1, 2x minus 1. But again, remember, we have to get the restriction first, right? Let's not forget that. So in this case, our restriction is that x cannot be 1 over 2, negative 1 over 2, 0, or negative 3. It cannot be these numbers. So be really careful in terms of canceling. So we have then reducing part. So 2x minus 1, 2x minus 1, they're gone. Now 8 and 4, so 8 becomes 2, x squared becomes just x. There's nothing else we can cancel because there's no similar or the same terms. So all I have left to then is 2x plus 3 over 2x plus 1 times 2 over x plus 3. So in this case, you can simply leave your answer as a 4x plus 6, or you can even leave it this way too, 2 and then 2x plus 3 over 2x plus 1 and then x plus 3. So in this case, again, your denominator in the final stage is different from your initial stage, and that tells you that your conclusion on your restrictions can be different. Therefore, you have to take the restrictions from the initial stage instead of the first stage. Now, some of you may ask me whether you have to expand it or not. I recommend not to unless a question is asking you to do, okay? So I'll say we just leave it that way, okay? Now, then let's take a look at the division. Division works the same way, okay? But all you have to do is you basically flip whatever the rational expression followed by the division sign, which is this, right? Now, the part that you have to be careful of with the division is the restriction part. So restriction of division is actually the value that makes the denominator 0 before and after, okay? And the reason is very simple. I'll explain this as I do the example here, okay? So let's take a look at the first example. So then the first thing is always we factor this completely. So we have 8m and then m minus 3 and then m plus 3 divided by 2m cubed over m minus 3. So first we have to look at what's making my bottom part 0. So if you take a look at these two, it's actually quite simple. My restriction is then m cannot be 3 or negative 3, right? Now, if you then take a look at this, then m cannot be 3, so it's good that we don't have to find it. The reason why we have to look at this one too is because even though it's division, we cannot have a number over 0, right? We cannot say 2 divided by a number of 0 because this is undefined to begin with already. Now, then that's easy. But then why can we have the numerator be 0? Well, if you have, let's say, 2 divided by 4 over 0, which is impossible, and then we change this, and what if we have 2 divided by 0 over 5? Now, this actually becomes 2 times 5 over 0, and this itself is also, again, a undefined So that's why we cannot have both the numerator and the denominator be 0 when you're doing the division of a rational functions. Okay, so I can erase it. So in this case, then your m, so I'm gonna follow the order. So we have 8m over m minus 3 and then m plus 3, and then times it is m minus 3 over 2m cubed. So again, we have to take a look at what the denominator is after flipping. So m also cannot be equal to 0. So you have 3 restrictions, okay? So then we just need to cancel things around and then simplify it. So we have m minus 3, m minus 3. We have 8 and 2, so that's 4 and that's 1. Now m goes away, so that should be 2. So your final answer then is 4 over m plus 3 times 1 over m squared. So at the end it becomes 4 over m plus 3 and times m squared, and that's completely fine. Now then let's try b. Okay, so this was the a. Now let's try b. Now b, same way, it's the same division. So what I want you to do is I want you to try this by pausing the video. So pause the video now and try this. Hopefully you have tried it. Okay, so again, the same way, you have to factor every single thing. So we have 5m cubed over m minus 4 and then m plus 4. I'm not going to take too much time on the factoring anymore because I assume that you have practiced your factoring skills a lot. Divided by 20m over m minus 4. Okay, now so the restriction has to be found before and after the flipping. So before flipping, we have this being 0, this being 0, this being 0, and they cannot be 0 actually. So the numbers are m cannot be 4 or negative 4. Then we have to flip it. Okay, we have to flip it. So we have 5m cubed over m minus 4 and then m plus 4, and then times m minus 4 over 20m. So in this case, we have 20m in the bottom. Therefore, this also is part of the restriction. Now then we start canceling. So canceling part shouldn't be a difficult part. So m minus 4, m minus 4. Now then 5 and 20, so the 20 becomes 4. M cubed becomes m squared, and this m goes away. So at the end, what you have here is then m squared over m plus 4 times 1 over 4. And that, you can leave your answer as a m squared over 4 times m plus 4, and that's completely fine. Okay, so hopefully everything so far is okay. Then let's move on to the addition and subtraction. Okay, so let's move on to the next page. So the next page is about the addition or subtraction. Now addition, subtraction, they're literally the same idea. Okay, just one is subtracting, one is the adding. Now when you do this, the first step is the same. You have to factor it fully and then state the restriction. So multiplication, division is the same way, right? And then you have to cancel the common terms. So always state the restriction and then cancel it, not the other way around. Then what you have to do is find what factor is shared in the denominator. So you're basically looking for the common denominator here. When you find the common denominator, you have to combine them, and then it will be your actual common denominator as the one big fraction. Now, once you have that, you have to have a big fraction, and then you have to multiply what's not there to the denominator, so to the numerator of your previous fractions. Now, this seems complicated, but if you actually take a look at the example, it becomes quite simple enough. Okay, so let's take a look at the first example here. We have y plus 2 over 6 minus 3y minus 5 over 4 equals 1. Well, this is a simple number, so what I'm going to do is I'm just going to multiply all the denominators all together. So I multiply this by 4, this by 6, and this by obviously 24, right? So it will be times 4 here 2, times 6 here 2. So I have 4y plus 8 over 24 minus, and then over minus 3y minus 5 times 6 plus 24. So this is what I mean by the big fraction, okay? So then this equals 4y plus 8 minus 18y. I'm going to rewrite this times 6 as this way. Plus 30 plus 24 over 24. Now then this then becomes negative 14y, and then plus, that is a 62 over 24. Now all you have to do is a simplification. So these can be divided by all 2. So then I have negative 7y plus 31 over 12. So this is the answer, okay? Okay. Now then let's take a look at the next one. Now this one fits more or better to the model and the steps that I introduced. So if you take a look at the denominators, what is the common denominator? Well, the common denominator here is x, isn't it? So your common denominator is x, and then whatever that's not here is then 2x from the first one, and then 3, and then x squared. So you probably are confused a bit. If you take a look at each, the common denominator is x. So your part of the common denominator is just x, okay? And then from the 2x squared, other than if you take a look at the 2x squared, if you divide that by the common denominator here, which is x, what's left there is 2x, isn't it? And then the next one, from the 3x, what's left is then 3. And from the last one, the x cubed, what's left is x squared. So your common denominator is basically this, okay? Instead of multiplying all these 3. So then, how do we determine what the numerator is? Well, the numerator is basically this. So let's simplify the denominator. So the denominator is then, I'll just write it, is then x times 2x times 3 times x squared. So if you look at 2x squared, what's missing is then 3 and the x squared. So you are going to multiply the numerator, which is 5, by what's missing. So 3x squared. This is what you're going to multiply to the numerator. Now, if you look at this numerator with the 3x, what's missing is x, 2x, and the x squared. So you are going to multiply this positive 1 by x, and then times 2x, and then times x squared. Okay. Now the next, for this negative 2, what's missing here, comparing this x cubed and then this whole common denominator, is then x, 2x, and then 3. Actually, it's just 2x and 3, right? Because this x and x squared becomes x cubed. So then you have 2 times 2x times 3. So all we have to do now is just to simplify the top, and everything should be okay. So we have 15x squared plus 2x to the power of 4 minus 12x over, what is this? 6, and then 6x to the power of 4. Okay, so hopefully that's okay. Oh, by the way, there's got to be no x here, right? Because 3x has x and 3, so it doesn't have 2x and then the x squared. That's why we have to multiply these two here, okay? So hopefully you're not confused. So this has to be cubed here too. So we're okay. Then all we have to do is just to rearrange them from higher order to the lower order. So we have 2x cubed plus 15x squared minus 12x over 6x to the power of 4. So in this case, we don't have to simplify anything because it's been already simplified. So again, the key is finding what's common of these, and then put the common with the uncommons, and then you find what's not shared, and then multiply that to the top. Okay, so let's take a look at this one. So here we have these two. So what I'm going to do is I'm going to factor these out. So 3, and then I have x plus 1 plus 2, and then I have 4x plus 1. Now here the common factor is x plus 1, right? So I put the big fraction, and then you have x plus 1 as the common, and then what's not being part of it is going to be multiplied together in the bottom part. Okay, so what's in common, you basically write it once. So what's not in common, you basically just write all of them. Okay, Now, then if you take a look at the first one, we have 3x and 3x plus 1. So these two are being in the bottom already. So what's missing is then 4. So the top, which is 5, has to be multiplied by 4. And then same thing goes for this positive 2. Here we have 4 and x plus 1. So 4 is here, x plus 1 is here. What's missing then is 3. So you multiply it by what's missing. Okay. So then all you have to do is to simplify the top portion of it. All you have to do is then 20 plus 6 over x plus 1 times 12. Now, then this becomes 26 over 12x plus 1. And then we can simplify these two. So this becomes 13 and 6. So 13 over 6, x plus 1. Okay. Now the last one, and I'm going to say this is the last one and call it a day because the word problems, I will actually do it with you after I cover this in class. Okay, I think it is better for us to do that way. So let's take a look at this one. So the first work is to factor the whole thing. So we have 4m over, and then I have 2m, and then m, I have then 3, and then 1. This should be minus, this should be, this should be 2, and then this has to be minus, this has to be plus. And then plus m plus 3 over, then you have m and m, and then you have 2 and 8 plus m minus. Okay, so double check whether my factoring is correct. I'm just doing this in my head. I'm pretty sure it is correct though. Okay, now then if you look at it, the common terms are these two. So you write a big fraction and then you write the common term once. And then what's not in common, you basically just bring them down and then copy them in the denominator. That's all that is. Okay, so then your job is to compare them. Now from the first one, from this, if you compare that to the whole here, what's missing is the m plus 8, right? So you multiply 4m by m plus 8. Now then if you compare this to the whole bottom here, then what's missing is 2m plus 3. So you have plus m plus 3 times 2m plus 3. Okay, so all you have to now do is expand the top, leave the bottom. Okay, then we have 4m squared plus 32m. Now then plus 2m squared plus 9m plus 9. Now the reason why it's 9m, I just basically expanded, right? I just expanded. So it's 2m squared, and then this gives me 3m, and then this gives me 6m. So that's why. Okay. So we have then over m minus 2, and then 2m plus 3, and then m plus 8. So at the end we have 6m squared plus 41m plus 9 over these three brackets in your denominator. Now I haven't done finding the restrictions, but it's pretty much the same drill as before, so you shouldn't be struggling with that one for now. Okay, if you still do struggle, that is fine. Just bring that to me and then see whether we can figure that out again. Now the 6m squared plus 41m plus 9, is it factorable? Well, it is not factorable in this case, I think, because we have 3 and 3 and 1 and 6, or 9 and 6. Yeah, it's not factorable. So you basically stop there. Okay, so hopefully the addition and subtraction part was okay. This is kind of difficult. It's not an easy one. So again, the key is you find the common and you write the common only once. Okay, if you go back to B, right, you find the common, you write the common only once, and you put all the uncommon ones together. So from 2x squared, the uncommon one with the x is then 2x. From the 3x, other than the x, which is the common one, the uncommon one is 3, so I put 3. And from x cubed, other than the x, which is the common part, the uncommon part of the x cubed then is the x squared, right? So as long as you understand that part, then the rest becomes actually quite simple, easy. So I'll see you guys in class. Hopefully you enjoy your Halloween, and I'll see you on Tuesday. Okay, bye guys.